Today we're going to do a review of rates and ratios. This was one of the very first things we learned about this year. So in your table of contents and at the top of your page, write rates and ratios review. Rates and ratios review. Like with our other review lessons, you don't have to copy all the notes if you still have those from when we did this earlier this year, but do work all of the example problems with me. That's what I will be checking. So first, let's review what are equivalent ratios. Equivalent ratios are ratios that represent the same relationship. They can either be scaled up or scaled down to equal the same thing. So 1 to 3, 2 to 6, 4 to 12, those are all equivalent ratios. So go ahead on your own and find a ratio that would be equivalent to 12 to 15, but with lesser terms. Hit pause and write that down. When you're ready to check your answer, hit play. So an equivalent ratio to 12 to 15, if we divided by the same number on the top and the bottom, 3, we would get 4 to 5. That would be an equivalent ratio. We can't divide by two different things because then the ratio wouldn't be equivalent. All right, next, what is a rate and what is a unit rate? A rate is a ratio that compares quantities measured in different units, and then a unit rate is a rate for 1 unit of a given quantity. It's like per one of something, so like miles per hour or something like that. So here we have an example. What is the rate if a car drives 120 miles on 4 tanks of gas? So we would write that rate as a fraction. We want to make sure we label the units. 120 miles for 4 tanks. That's just the rate. Now, when they ask us for the unit rate, we are going to simplify this. We're going to divide by whatever number is in the denominator. Okay? And that's going to give us 30 miles per 1 tank. Okay? So we would divide by whatever the number is in the denominator so that we get the denominator to equal 1. That's going to be our unit rate. On your own, find what would be the number of times per year, that unit rate, that this lobster molts. If it molts 20 times in 5 years, how many times per 1 year does it molt? So if I have the unit rate of 20, or sorry, not the unit rate, just the rate, 20 times that the lobster molts in 5 years, then I would divide by this number in the denominator to get a denominator of 1 year. That's going to tell us how many times per year. Divided by 5, we would get 4 times per year. Isn't that fun? Okay. I think we get the point of this. So if we were to do this, we would just divide 219 by 3. All right, next, a unit price is a type of unit rate. It's finding the cost per item, though. Okay, so instead of talking about per one something, we're talking about the cost per one item. So here, if we have $25 for 4 tickets, go ahead on your own, hit pause, and find what the unit cost would be per ticket. Hit pause, find the unit cost per ticket. So if we have $25 for 4 tickets, again, I divide by the number in the denominator to get that denominator of 1. It would be $6.25 per ticket. All right, on your own, I want you to find the unit rate for each of these packs of t-shirts. We know that we can get 15 shirts for $47.25. We can get 8 shirts for $27.20. So let's call this shirt A, package A, and we'll call this package B. Okay? Now I want you to compare and figure out which is going to be the better buy. Now how can I compare them? I want to find the unit cost. Now sometimes I see students do this 15 over 47.25. Remember, we want to find the price per item. So the price is supposed to go on the top of our little rate, or ratio, whatever. So we have that cost for 15 shirts, and then we have this cost for 8 shirts. So I'm going to, again, divide by the denominator to to find the unit cost. $47.25 divided by 15. That's going to be $3.15 per shirt. Here I'm going to divide by 8. And that's going to be $3.40 per shirt. So which is the better buy? Which is the better buy? A. It's cheaper. Per shirt, it's cheaper. So even though we're paying more up front, if we calculate what is the price per individual shirt, it is cheaper to get package A. Okay, last thing to talk about is ratios and rates that deal with fractions. And these work just like complex fractions. We reviewed how to do complex fractions. So we're going to have either a ratio or maybe a rate that compares one fraction to another fraction. We find that main fraction bar, that ratio bar that compares the two numbers, and we write it like a dividing fractions problem. So in this problem, 4/5 inches to 6 inches, we would write 4/5 divided by 6 over 1. And then we know that we multiply by the reciprocal. So times 1 over 6. Times 1 over 6. From there, I see that I can cross cancel my 4 and my 6. Make this a little easier. And then 2 times 1 is 2. And 5 times 3 is 15. I know it flips last, but oh well. Okay, so 2 to 15 would be that simplified ratio. All right, last one, unit rates with fractions, same difference. It's the same thing. To find the unit rate, set up the rate, and then divide by the denominator. So we're going to divide, keep, change, flip. Let's do this one. 3/4 a cup of dry milk powder to make 6 dog biscuits. We want to find how many cups of milk powder do you need per dog biscuit. So that's telling me the order. 3/4 a cup for 6 dog biscuits. Biscuits. Alright, and then 3/4 divided by 6. That's 6 over 1. So that would be 3/4 times 1 over 6. Can I cross cancel? Yes, I can do those. So this would be 2 and this would be 1. 1 times 1 is 1. 4 times 2 is 8. So my simplified rate would be 1/8. Okay, so that would be 1/8 of a cup of milk powder per dog biscuit. At this point, you should be ready to start on the digits assignment for ratios and rates. Let me know if you need help.